everyone, welcome to Project BlackBox, and today we are going to actually complete a machine learning project on Python. And I have chose this dataset from Kaggle named insurance.csv. This is a dataset consisting of all these features named age, which is basically the age of the person, the sex, which is basically the gender of the person, the body mass index of the person, the number of children covered by the health insurance of the person, the smoking habits of the person, which is basically whether the person is a smoker or a non-smoker, the region of the person, and this is basically a data set based on US. So we have regions like Northeast, Southeast, Southwest, and Northwest. And finally, we have our predictor variable, which is basically our dependent variable, which is called charges. And this charges is basically individual medical cost billed by health insurance. So we have a data set which is a medical data set, and these are the features which actually led to the cost of medical cost, which is basically covered by the health insurance. So we are going to use this data set to build our machine learning project, and you can easily find it in Kaggle if you just write in the insurance.csv. And this is a medical dataset that we will use. So I have already downloaded this dataset using this, and we will be using the Google Collaboratory, so you need not install anything. And I'll share the code and the dataset also in the GitHub, so you can just go to the description of this video and find the GitHub link to the project. So let me just go to my Google Drive. So in my Google Drive, I have a folder named projects, and inside it I have another folder named medical cost prediction. So I am going to upload my dataset here. So since I have already downloaded it, let me just upload it. I have used the drag and drop. You can also do that. So as you can see, I have uploaded my dataset within seconds. Now we are going to use Google Collaboratory, which is basically an app by Google, which basically replicates Jupyter notebook environments of Python. So in order to use that, you can just right click here and you will get something called more. And if you go to more, you will find the Google Collaboratory. So if you click on it, you will be redirected to the Google Collaboratory, and you will get a untitled file and new file which you can work on. So as you can see, I have my environment ready. So first of all, let me just go to this file section, and this will just start allocating my memory. So what Google Colabs does is it basically gives you a runtime environment, and you get a virtual machine of and in this virtual machine you can also opt for GPUs and TPUs if you want. So this is basically meant for Python developers who work on machine learning and data science projects. So you can see my runtime is connected, and I have gotten something called 12 GB of RAM and something like 100 GB of storage. So let me just mount my drive, and why we are going to do that is because we have uploaded our dataset to the drive because we want to access it. So in order to get the dataset into my collaboratory file, I have to mount my drive, and you have to click on connect to Google Drive. So after your drive is mounted, you will get this pop-up named drive, and we will use this. So let me just first import a few basic libraries that we will use throughout this video. So first of all, I'll be importing pandas as PD. So pandas is basically a data analytics tool, and it is a very popular library of Python used for data analytics. We will see into a few methods of it, and I'll also import numpy as np. So NumPy is basically used for array computation and mathematical computations also. So I'll also import matplotlib.pyplot as plt. So this is basically a data visualization library of matplotlib, and based on this library we have something called cbon, which is also a visualization tool, but it gives multiple features and custom visualizations for your data. So I'm just going to import cbon as SNS. So let me just run this cell, and in order to run this cell I am using control enter. And if you want to just uh, run this cell and move on to a next cell, you can just press on shift enter. So let me just press shift enter, and as you can see I have already run this cell and I have jumped to a new cell. Now in order to access the CSV file and predict our model, we have to import it into this environment and make use of it. So in order to do that, I'm just using a variable named df, and I'm going to use the pd.read underscore CSV method. So this basically reads any CSV file and converts it into a data frame, and inside this double quotes you have to pass on the path of your dataset. So let me just go to the drive folder, and then I have something called my drive. There I have this projects, and inside this projects I have medical cost prediction. So here I have uploaded my dataset, and in order to copy the path I have to click on these three dots and I have to copy this path, and after I've copied it I have to paste it within this double quotes. So if I run this cell, my data frame is now loaded into my df variable. So if I just write df.head of 10, so this will just basically give me the first 10 rows of my dataset. So you can see I have gotten the first 10 rows of our dataset, and we have all these features that we looked on in Kaggle. So now just by looking at the dataset we know that this is not actually appropriate for any machine learning project, because we have something called categorical variables here. So any machine learning model that you have works basically better with some numerical data instead of this string type data. So let us just check the types of this data set. So if I write df.dtypes, it will return all the data types that are inside this data set for each column. So you can see age is int64, sex is object, which is basically string type, and so on. So in order to change this, we can use something called map. So map is an inbuilt function in pandas that we can use. So I'll show you how we can do that. So in order to do that, let me just create a dictionary. In order to do that, we actually have to create dictionaries only. So I am creating the first dictionary for my sex column. So I am writing female, and you have to give this column, and I am giving 0, and for male I want 1. Similarly, for my smoker column, I want the yes to be changed to 1 and the no to be changed to 0. So I'm writing yes, and remember they are strings, so you have to pass them on as strings. Yes equals to 1, and this is not equals to, my bad, it's colon, and no would change to 0. So I have written this dictionary, but how will I use this to actually change my categorical variables? So in order to do that, it is very easy. I just have to locate my column. So I am writing df of sex equals to df of x dot map, which is my inbuilt function, and I just have to pass on this dictionary. So I'm passing on the dictionary, and what this will do is it will iterate through the entire column and search for the females and convert them to 0, and search for the males and convert them to 1. Similarly, let's do it for the smoker column also. So df of smoker is equal to df of smoker dot map. I'm going to pass on map1. So I hope you all are able to understand this, and do not skip this video, otherwise you won't be able to understand the entire project. So as you can see, I've written this code, and if I run this code, it will just change all my categorical variables into zeros and ones. Now let's have a look at the data to actually understand what happened. So if I write df.head of 10 and check into the first 10 rows again, so you can see that all these is changed to zeros and ones. So you can see the first one was female, I guess. So see, female has turned to 0 and male has turned to 1. Similarly for the smoker variable, yes has turned to 1 and no's are changed to zeros. So pretty much amazing how what all you can do with just a few lines of code in Python and pandas. So we have one more categorical variable left named region, which we have to change now. So you can just go ahead and use the sklearn one hot encoding module, but for beginners I am actually designing this project, so I want to do it manually. So I'll create a temporary variable named temp, and I'll use the pd dot get dummies function, and this will basically give me all the dummies of this region variable. It will be more clear when I show you. So let me just write in df of region and temp dot head of 10. If I write, so what happened basically is each one of these columns, that unique variables that we have, has been transferred into a vector as a data frame. So you can see the first one was southwest. So in the first row only southwest has a 1. In the second row we had this southeast, so only southeast has 1. So this has completely changed into a vector format. So now we do not need this region column in my data frame. So I'll just remove it using the df dot drop method. So I'll just drop the feature, and in order to do that I have to actually write in the region inside this double quotes. I have to give the axis equals to 1 so that it understands that I want to remove the entire column. If I just write axis equals to 0, it will just remove rows. So in order to remove your columns, you have to write axis equals to 1. And one more thing that I have to write is comma in place equals to true. Now what this will do is this will permanently remove it from the data frame, otherwise it would be only temporarily removed. So now if I write df dot head, I should get all the features except region. So you can see I am getting all the features except region. Now I have gone this far, but I want to actually concatenate my temporary data frame that I created with my original data frame so that I can use these features also. So in order to do that, I'll just use df equals to pd dot concat, which is basically a concatenation function of pandas. So you can see how pandas is actually helping me throughout the project to actually do all the data analysis and cleaning part. So in order to concatenate two data frames, you have to pass them on inside a list. So I am just creating a list, and inside it I am passing df comma my temporary data frame. And you also have to write axis equals to 1, because we want the columns to be concatenated and not the rows. So now I think my data is completely ready. If I write df.head of 10, and it should give me the results. Yes, as you can see, we have successfully concatenated this temporary data frame into our original data frame. And now it is time for the machine learning part. So we will just use linear regression, which is basically to predict these values. So whenever we want to predict some values, we use regression as my machine learning model, and in order to predict some class labels, we use classification. So before doing that, we always, split our data into training and testing, so that our data is not overfitted, which is basically it does not have a lot of bias. We do not want our data to be biased, our model to be biased. So I'm going to split my data. So you do not need to split the data manually. We have a function called train test split in the sklearn. So I'll write from sklearn dot model underscore selection import train test split, and I'm going to write, oh actually I have to store it into x and y also. So let me just write in y equals to df of, so what is my y variable? What in y we actually store our predictor variable. So I'm just going to store the charges. So y is equal to df of charges, and x equals to everything except the charges. So x equals to df dot drop charges comma axis equals 1. So now if I look at x, so you can see x has everything except the charges, and if I have a look at y, so y just has my charges, which is the pricing. So now I want to split this data so that I can use for testing also. So I will write x train comma x test comma y train comma y test equals to train test split, and I have to pass on the parameters x and y because I want to split the x and y into different samples, and I am setting the random state parameter to 0 because I do not want it to change for everyone who runs this code. And I also am using the test size parameter. So I want my test size to be 15%, so I will signify this as 0.15. So this will automatically change my training size to 85%. So after I have done this, I'll just run this cell, and now we can actually use the linear regression to actually um, train our model. So before we do that, let's actually visualize some part of the data. So I'll write plt.figure, and I'll set the fixed size parameter to a tuple of 20, 20, which is basically the size that I want for the visualization. And this is how matplotlib is helping me, and I am going to create this custom visualization. So before that, let me show you the correlation between the features. So I'll say df.corr, and you can see that how the features are correlated between each other. So it would be better if we can visualize this so that we can understand it in a better way. So that is why we are using custom visualizations. So I'll write sns, which is my seaborn dot heat map, and I want this correlation to be in my heat map. So I'm passing on the df.corr. I want my annotations to be set to true. So this will basically give me these labels like age, sex and all. Also, I want my styling to be in the cool warm way. And let me see if I want some other parameters to make use of. So I want the line widths set to 2 so that there are even spaces and I can actually look into it. So whenever I run this cell, I will get a beautiful visualization of this correlation heat map. So you can see how beautiful this is, and this is the scale of the collinearity. So this specifies that the data is not very correlated, and as you go up to the scale you will find the data to be more correlated. So we can see that these are very highly correlated. These have a score of 1. So these are nothing but basically correlated to themselves. So age would be obviously completely correlated to age because it is age only. So it's completely correlated to itself. And we have one more thing that is correlated, that is my smoker is completely correlated with charges. So guys, if you are a smoker you will have high medical charges, so our data is appropriate now. So since we have this high correlation between the smoker and the charges, let me actually plot them and see how it goes. So to do that I will make use of the matplotlib library again. So I'll write plt.figure and fixed size equals, again I'll pass on a tuple. So I'll say this time 12, 9. This should give me a appropriate size. I'll also write plt dot scatter since I want a scatter plot, and I will pass on my x as df of smoker, and my y would be df of, actually df we have removed it from df, so I just have to pass on y because I've stored the charges as y. And I have to set the plt dot x label. So I want to label it as um, non-smoker versus smoker, and plt dot y label, this will just, I'll just write it as charges. So if I just run this code we shall have, okay, so it is working. So you can see the people who are non-smokers have a average costing of charges from around 0 to approximately 38,000 we can say, and the people who are smokers, which is basically my one, have a spending of around 12,000 to above 60,000. So there is a huge difference. As you can see that it is kind of a polynomial. It is forming kind of a polynomial here. So we will make use of this information that we have just gotten from our data. So remember, we had already used the train test split method, so I'll just use it to feed my linear regression module. So I'll just import from sklearn dot linear model import linear regression. So let me just create an object of the linear regression class, and the fit method will basically train my model based on whatever x and y value I pass on. So in order to pass the x and y values, since we want to train it on training data, so I'll just pass on my x train comma y train. So remember, never use your testing data to train your model, always use your training data, and this will just train my model. And I also want to predict my x, which is my testing data. So I will write something called y predict equals to reg dot predict, and I will pass on x test. So I want to predict x test, right? I want to predict the x for the testing data. So I will look into this y, and if I run this cell, alright, we have done that. So I want to check the accuracy of my model right now. So in order to do that, I am just importing the R square, which is basically a metric. So from sklearn dot metrics import R2 score. So I want to check the R2 score of, and the format for this is always y true comma y predicted. So in this case, my y true is basically the testing y that I had, which is my actual labels. So I have y test comma the predicted y that we have, which is my y underscore pred. So if I just run this cell, you can see I am getting somewhat of 79% accuracy, which is not bad, which is good. But we will try to improve this, since we got that it has some polynomial kind of features. So we will try the polynomial regression also. So let me just import from sklearn dot pre-processing import polynomial features. So I have to create an object of it. So I'm writing pol equals to polynomial features, and I want the degree to be set to 2 at first. So let me actually store my x into a temporary variable again. So I'm writing px equals to x, and I'll just write in px equals to pol dot fit underscore transform. This will just change my x variable, whatever I have, into a second degree polynomial, because we have selected the degree equals to 2. So if I pass on the x and look into my px, it should give me this array. So it has converted successfully into a second degree polynomial. So if I now use this to actually train my model, let's see how it performs. So I'll write again, let me just copy that code. Why do it again and again when we can just copy the code, right? So I'll just copy this code, actually not cut, I will copy this code, and I will paste it, and I'll only change my x from x to px. Sorry, change it to px. And if I run this cell, I will get the data into my training and testing. So let me just again copy this code, paste it here, copy this code also, and paste it here. Guys, I'm just doing this to save time. And linear regression. Okay, so this should just give me the new r square. Okay, this is not closed. Okay, so we are getting 87% accuracy, guys. That is a great accuracy that we are getting. So let's also check the cross validation score. So cross validation is basically using different samples to actually check that our model is not overfitted. So from sklearn dot model selection, I am importing the cross val score, and I want the cross c equals to cross val score, and you have to pass on the model that you have trained, which is basically my reg. You have to pass your x and y, which is basically my px, and y is my y, and you have to pass on how many samples you want to divide it into. So I want to divide it into cv equals to 4 samples. So let's check the list. So it is giving me something like this, and if I write just c dot mean, it will give me the mean accuracy. So it is 81%, which is completely fine to be deployed. So let us actually do a little more tricky thing. Let us just convert this into a third degree polynomial and see how this works. So I'll just store x into px again, and I'll run this cell. Now let's run this cell again with the degree equals to 3. So it will convert the x into a third degree polynomial. Let's split it again, and let's check the score again. So it is giving me 87% this time also. Now if I run this cell, and if I check the mean, so from 81 we got an 82% accuracy. So we have increased our cross validation score, and our model is completely ready. So this was our basics on a machine learning project, and I did a full-on project in front of you. So you can find the code in the description from the GitHub. And if you like this video, don't forget to hit a like and share it with your friends so that they can also do this project. This is a very easy project that you can do. Also subscribe the channel if you have not already subscribed, and I'll see you in some other video. Till then, take care.